Hello, guys. How are you doing? Welcome to part two of the higher paper two AQA GCSE maths revision. Wow, that is a lot to say. Anyway, so we've got question eight. A music festival has taken place for each year from 2011, and we've got the table that shows the number of people who attended each year. Okay, so the festival organizers draw a time series graph to represent the data. The first 4 years have been plotted. The festival organizers draw a time series graph to represent the data. The first 4 years have been plotted. Wow, he only did four of them. So we've got to complete it. See how we've got to do everything as a mathematician. Oh dear. Right, so we've got, let's do our bit in blue. 2014's been done. We've got 2015, and that's been said to be 2023. So we've got to go 2000. Each line is going to be worth 100. So it's like really in between the 2000 and the first little line. It's going to be very hard to be precise, but let's draw a cross roughly. Then we've got 2016, which is going to be 2,612 people. So 2,500 is here, 2,600. So 2,612 is a little bit higher. So again, it's not perfect because my line is kind of thick, but it's okay. And then 2017 is 3,251. So we've got, 3,200. So that's here, and that's in between this line and the 3,300 line, so about halfway. Cool. And then next we've got 2018, which is 3,780. So we've got 3,500, 3,600, 3,700. It's kind of close to 3,800. So I'm going to put it like kind of close to the third line, but not quite there. Ooh, there, that's too far. That's too far. Let's go back. Let's rub that out. Getting this is pretty tough. In fact, what am I doing? I can just zoom and zoom. Okay, so that makes it a bit easier. So what's my number? 3,780, right? So 3,780. So it's like roughly here. Again, kind of hard to get precise, even with me zooming in, but it's okay. And then the next part of the question, oh, wait, I haven't even finished. I need to actually draw the straight lines that connect these things. I should have a straight line option. Yeah, that's good. So let's connect a line there. Let's connect a line between there and there. Let's connect a line between there and there. And then one between here and here. So next is asking us to use the graph to estimate the number of people who will attend the festival in 2019. Well, if we kind of carry on this this trajectory, let's do that in pink. We would like a good pink. Let's just put it in this rough kind of direction. You know, that's probably a good estimate, given that it's going up, it's continuing to go up in that kind of pattern. And 2019 is roughly here. So it's roughly 4,250. That's a good estimate, I would say. Oops. The most important thing is that you use your graph and you add an extension, and you're showing the examiner that, look, I'm out here using my graph to make an estimate. I'm not just guessing. People that say estimate means guess, oh dear. No, no, no. You're using information that you have to then make some kind of prediction. Okay. Right, next question. Work out the highest common factor of 15 and 20. Okay, well, The factors of 15 are 1 and 15. I'm going to write them in factor pairs, 3 and 5. The factors of 20 are 1 and 20, 2 and 10, 4 and 5. So we see here the common factors. Of the common factors, the highest one that is in both lists is 5. So that gives us 5 is our highest common factor. Lowest common multiples of 6 and 8. Well, the multiples of 6 are 6, 12, 18, 24, 30, and so on. And then for 8, we've got 8, 16, 24, 32, 40, and so on. And the first number that appears in both lists is 24. So we're sweet there. Okay, next, write down 132 as a product of prime factors. So we do our little factor tree right over here. So we've got 132. We just need two numbers that multiply to 132, where we're not using 1. So let's go for 66 and 2. That works. 2 is a prime number, so we circle it. Two numbers that multiply to give 66. We've got 11 and 6. 11 is a prime number, so we circle it. And then two numbers that multiply to give 6 are 3 and 2, and they are both prime. So 132 as a product is all these numbers circled and multiplied together. So 2 times 2 times 3 times 11. Now, this is enough to get you the 2 marks because the question did not specify index form, but I'm going to be nice and posh and write it in index form. So 2 squared multiplied by 3 multiplied by 11. Guys, you have to put the times sign because it says product. I've seen people put plus. I've seen people put divide. I've seen people put all these crazy symbols. It's got to be times, okay? Cool. Let's keep going. It says work out the highest common factor of 110 and 132. Well, we could do what we did before, where we just write out all the factors, but that's a bit long. What we're actually going to do is also write 110 as a product of prime factors. So 110 is going to be, well, we need two numbers that multiply to give 110. So that's 11 and 10. 11 can be circled because it's prime. And then we've got 10, which is 5 multiplied by 2. So again, these are both prime, so we circle those. There are many, many ways you can go about doing this. I'm just going to do it using the Venn diagram way because that's the way that I've seen a lot of students do it, so they seem to like that. I'm not going to fix what is not broken. So we've got a little circle there, and we've got another little circle there, and then that gives us 110 and 132. So what we now need to do, given that 110 is equal to 2 times 5 times 11, we need to find numbers that are in both lists. So if we compare 110 to 132, so this number and this number, we see that they both have a 2. So I can cross off a 2 here and here. So that goes in the middle of our Venn diagram. This 132 has a 2 that this 110 does not have. So I put an extra 2 here. And then I have this 3, which appears in 132, but not in 110. So that's going to go here. I have 11, which appears in 132 and in 110. So that's going to go over here. And then this 5 appears in 110, but not in 132. So the highest common factor now is going to be everything in the intersection or in the intersect of the Venn diagrams, this bit that overlaps, multiply together. So that's going to give us 22, 2 little ducks. Okay, yeah, that's it. Side note, if you wanted to work out the lowest common multiple, you would multiply all the numbers in the Venn diagram, and that would give you the lowest common multiple. But we were asked to work out the highest common factor, so that's what we've done. Right, next question is circle the two roots of x minus 5 and x plus 3. So basically, when x minus 5 times x plus 3 is equal to 0, what are the values of x? So you've got two things multiplied to give you 0, which means that either x minus 5 equals 0 or x plus 3 equals 0. If x minus 5 equals 0, adding 5 to both sides gives us x equals 5. Or taking away 3 from both sides of the other one gives us that x is equal to minus 3. So our two roots are going to be 5 and minus 3. Does it? Next, we've got the graph y equals a plus bx minus x squared is shown. Let's make this a bit smaller because we don't really need it to be that big. It says circle the coordinates of the turning point of the curve. The turning point is this here, where it goes from an increasing function to a decreasing function. Okay, and we can see the coordinates of that are 2, 16. So there is our option there. Next, it says circle the value of a. Let's just go back. What the heck is a? It says the graph y equals a plus bx minus x squared is shown. Now, notice how a is the only thing that doesn't have an x next to it on the right-hand side. So if you were to substitute x equals 0, this essentially gives you the y-intercept. Okay, so you'd end up getting y equals a plus b times 0 minus 0 times 0, or just y equals a. So this is essentially for the y-intercept. And that y-intercept is going to be at 12. Happy days. Okay, so we can circle that as 12. Then the next question says, circle the roots of a plus bx minus x squared equals 0. So the roots, so again, we want to solve this equation. If it equals 0, this is where it's crossing the x-axis or where y is equal to 0. So looking at the graph, we can see it crosses the x-axis at minus 2 and at 6. So those are the roots. The roots are minus 2 and 6. Okay, where's the option for minus 2 and 6? There we go. All right. That's it for this video. There's another question on quadratic graphs, and we will do that in our next video. Take care, guys.